Welcome to the Databricks Skill Builder series. We're glad you're here.
Carrie, do you just want to give them a little bit of background about you?
Sure. Hi, I'm Carrie Ross. I'm Stephanie Saib Solutions Architect. I am out of Denver, Colorado, and I've been with Databricks a little over a year. And before Databricks, I was actually a customer. So excited to be here and talk about this optimizing performance and cost. It's something that is a little bit harder to dive into on your own from the blog. So what just dive in and I'll talk about our objectives for today and then how we can go about and help our customers. So first we're going to walk through the tuning and cost optimization and some of the challenges that people have that are at play when you're on Databricks and doing this tuning. And then we'll walk through the pricing model and considerations, some cluster management best practices on what type of instances are appropriate for workloads and how we can identify the correct number of instances. And then we'll talk a little bit the performance and tuning, mostly by looking at the Ganglia metrics that we have that are integrated in the platform, and then some quick tips and tricks at the end. And then after that, there are other advanced tuning workshops that we have scheduled, and we're probably going to schedule more in the future because it is a big topic. So with this, we really want to understand how Databricks charges for usage, how you can prepare a plan for managing the clusters, and then use those best practices. So for the background, there's a lot of knobs we're going to turn, but there's some expectations that we have around cost optimization and performance. So there's not a silver bullet or an algorithm where you're going to get the perfectly architected clusters. This is because there's a lot of different use cases, data, business needs. So there's not this one size fits all. But so when you're thinking about cluster sizing and cost management, you want to think about your SLAs. How fast does your job need to be? Do you want to throw more cores at the job? And if you're doing that, are you actually getting, do you need to spend that kind of money for more cores, or can you meet your SLAs with fewer instances and fewer cores? We're also going to think about the type of job. If our goal is to get just the right amount of cluster size for the application, you need to know about the data that's going to be used. And when the type of job we're thinking about, is this machine learning? Is this streaming, ETL? Is it interactive or development workloads? Or finally a production job? And experimentation is actually relatively cheap. So we always recommend people think about experimenting. So we're going to give these tips of how to get the rough order of magnitude, but you need to think about, is the perfectly architected cluster the most important, or is that getting that perfect cluster delaying your development time and actually rolling into production? And then there's some ideas of where can you make changes. So performance optimizations can be gained in many parts of both the platform, infrastructure, and application. So some of these to think about are code design. There's sometimes faster ways that you can design your code with data frames or Spark SQL or MLlib APIs. When you dive deeper beyond the code, there's looking, and we can see this in the Ganglia, shuffling tuning, if there's a lot of shuffle going on between the partitions. Databricks has also added a lot of features throughout the years. So looking at, can you use Delta Live tables or some other more current runtimes? One of the fastest ways to get more performance out of your clusters is the up-to-date runtimes, the most recent runtimes. There's also cluster types. And so we're seeing the slides that there's clusters that are memory optimized, and there's ones that are compute optimized. And in cluster size. So adding more cores where you get performance that is beneficial for your application. And many of you are familiar with the lakehouse architecture. So there's the data storage and format. and is it optimized on Databricks? We have a lot of features that are with the auto optimizations that can help a lot with small file problems and shuffle. And then, as I mentioned, Spark performance. One of the best advice is just, if you can, use the most recent runtimes. They have the most optimized engines, and each runtime we release is adding more and more under the hood, so people don't have to think as much about your partitions and as much about these different performance metrics. So really, this background is the main takeaway. There's lots of best practices that we're going to go through, but think of these high level, the different levers that you can pull. So, and this is more on the background with the performance requirements. We want to establish what this actually means in the terms of development, ecosystem, and business. So with development performance, one of the most expensive resources are the people. It's often left out of performance metrics, but you want to make sure that your developers are having enough scale with their clusters that they can get their job done efficiently, especially while they're doing experimentation. And then with the ecosystem performance is the amount of time and throughput. Where is your bottleneck? Is it in the Databricks cluster? Is it in the ingest? Or are there other technologies that are waiting for this data? So it's the bottleneck is in this processing or training, or is the data backing up and you can actually slow down your cluster, use smaller clusters and slow down. That goes into the business too of what are the SLAs. Okay, so that's the background. So the basic elements of cost and performance. There are really three basic elements. There's the raw pricing, which is based on the DBU and the cloud provider that you're on. And the combination of these is what you get your total cost of ownership. And then there's the type of jobs. High level, there's typically been the automated and interactive, and we've also added some more with the SQL workloads. And then finally, that cluster configuration and the hardware and the runtime considerations. So pricing. There's two main components, as we said. There's the DBU and there's the vendor billing. So one, for what a DBU is, it's a Databricks unit. One instance running for an hour is an instance hour. And you also have that processing power that you have running on the VMs. So with one DBU is roughly, if you're on, let's see, Azure, it would be like a standard D12 V2 memory optimized is what we actually get for the one standard DBU is what you can process on that VM. When you're selecting your VMs on your runtime in your workspace or your API, you can see the different DBU costs. So a couple of questions that often come up with this, especially when you're doing your all-purpose compute, is when you add more notebooks to all-purpose compute, does it cost more? And the answer is no. It was based on that DBU usage and the VM cost. Additionally, you start getting charged for a DBU once the virtual machine is up and the Spark context is initialized. So there's a little portion of the startup cost, but not all of it. Overall, in the general scheme of things, this is small, but it's just it's good to be aware of. So I briefly started mentioning this, but we have these different DBU pricing tiers. I put the three that are very commonly used in the blue. We have this all-purpose compute. This is what you see is commonly used with the machine learning interactive clusters. They're also called interactive clusters. It's the de facto for interactive. So it lets you attach Databricks notebooks. That's where you get your built-in visualizations and dashboards. And so you can really unlock that power of data science and productivity. Within the all-purpose compute, we do have auto-scaling And we also have these high concurrency features. So if you're haven't dove into the clusters a lot, high concurrency cluster it's a managed cloud resource. The benefit is it really helps for maximizing resource utilization and sharing when a cluster is up. So, and you also get fault isolation. So many people can attach to the same cluster, you get many notebooks, and they're effectively isolated from each other. So that's when you select your interactive, you can decide if you want that high concurrency. The jobs compute, this is really the de facto for automated workloads. This is the one where you've done your development, you've done your interactive experimentation, whether it be data engineering or data science, and now you want to run a job on either some schedule. And it also supports various external tools. So this is the one you're just going to run through your ecosystem. We do have a jobs compute lite that's actually not used very often. It's our cheapest SKU, but it is not as fully featured as other. It doesn't support as many of the connections and the other benefits. But if you really need to pare down and really cost concerned, it's something that people can consider. And the other pricing tiers are now the Delta Live tables and SQL compute. SQL compute is often very comparable to the jobs compute. This is where you have your SQL endpoints running a compute, really the data analyst, and ties to a lot of our BI tools. I put these links down here, and these go to the publicly shared pricing of Databricks on AWS, GCP, and Azure. Keep in mind that most companies have contracts, so these might not be your prices. You might have a lower price, or you might not, depending on your contract. So that's one, just reach out to your account team and they can help if you have questions about what your pricing are for these different tiers. And this is just a summary of how the total charge is. You look at the instance hour, which is your DBUs, and you look at the number of nodes you have. You're always going to have a driver node, which is this one here. And in this example, I've got 3 worker nodes. So you're going to take that times the number of hours, and that's the number of instance hours. So you've got 4 nodes in this example, where you have 1 driver and 3 workers. Up for 2 hours, you get 8. So you're going to get 8 DBU hours. And then your total charge, and this is an example, if you have AWS for 8 instance hours and you're running on an R4 extra large, you're going to get that cost for the VMs plus the DBU cost.
Hey, Carrie, I'm going to interrupt you real quick. We have a question asking about if using Job Lite is a good thing to use for your dev and test environment.
It's not as fully featured as what we have. So you might run into, you're not going to get the full benefit of the platform. And because, I'm sorry, did you say dev test or did you say development?
Like dev, like your dev environment or your test environment?
Okay, so I would say that in your dev environment, you probably want all the features that your developers need, and they are your most expensive costs. So it might be riskier to do that because you're not going to get the most up-to-date features that really are time saving. For your testing, if you want to make that effort to look, if you're very cost conscious and you want to make that effort to make sure that you have that compatibility, you could take a look at what the features are. It's on the our webpage of what the feature different lists are in that jobs compute lite. But it is there for people that are very cost conscious, and you don't need those extra features. Does that answer the question?
I think so.
Okay. Then I'm going to move to the cluster management and best practices. So we looked at the pricing, and this is how we actually can proactively configure and manage the clusters. So to start with, we have the driver and the executor. And whenever you have a cluster, you're going to have a driver, and you're going to have at least one executor. So the driver is the leader and it's going to coordinate everything for the executors. So the driver is maintaining information about the Spark application. It's responding to the user's input and output, and it's analyzing, distributing, and scheduling the work to the executors. It can sometimes be a bottleneck to your application, and we'll talk about that, and the Ganglia can help you determine if that is the bottleneck. The executors are responsible for doing a lot of the work, the actual work that the driver assigns to them. So each executor is responsible for two things. It executes a code that it's assigned to it by the driver by running these individual tasks. On the slide. And then reporting back to the driver what happened on the executor. A couple of things to note about how this cluster is configured is we have the number of cores and slots, and those are the ones that can actually do tasks. So when you say that you have, for instance, in this N cores, if we have 4, you would have 4 slots, and that can basically execute 4 different tasks. On your executor, you have storage memory and working memory. This can often be confusing to people when they're first starting to work with Spark, because they might say, hey, I have my executors have, 2 gigs of memory or something, a big memory. Why am I seeing out of memory errors? You don't have access to that full storage and work because some of it is working. Those are adjustable. We don't recommend you do that first of adjusting, because there needs to be always enough to do the actual work in the memory, but just keep in mind when you're selecting, you don't get access to that full memory. Okay. So when you're looking at the cluster considerations, you're going to look at the instance type. So those are the VMs, the number of workers, that standard versus high concurrency, which we talked about, and that depends on how your users are going to use the cluster. Your access control list. Auto termination is a feature we have, so it will turn off. This is beneficial on those interactive clusters, so people don't leave them on and run all through the night when no one's using them. Auto scaling. When I hop over to the Ganglia and look at our clusters, you'll see that you can scale. You can go from your minimum number of workers are going to be up to however you want to scale. And then on-demand versus spot. So the on-demand versus spot are a much cheaper way of running your clusters, but they actually have a little bit more risk if you can't get your spot instances. And then finally, there's cluster tagging, which can help you with chargeback and how you want to manage your costs internally. So looking at the different common types examples of instance types when you're selecting your cluster, you really want to look at if you think you're going to be memory optimized, compute, storage, or general purpose. These are examples. You can go and look on the Amazon and similar for the other clouds have these different, show the different grouping of clusters that are available, and you can start to look at the different instant types, the memory, and the types of storage access you have. But again, experimentation is good. So you can look at which ones you have in the cost. And if we look at, for instance, this R4, it has, if you look over here, oops, the memory optimized. You can see for this that the memory optimized for the CPU, for the number of cores, it has on the 1 or the 2, it has almost 1:8 ratio of CPU cores to memory. So it's recommended for memory intensive that process large data sets in memory. But similarly, if we looked at that web page for the compute optimized, you'll see that on the compute optimize, it's got 1 CPU to 2 gigabytes of RAM. And that helped, so that's a compute intensive where you're thinking of maybe structured streaming, distributed analytics, data science applications. For instance, in memory and machine learning workloads, commonly you have cache work or a data set that's going to be iterated through. So you might, if it's fully cached, it can save you time because if it's fully cached, you can use less than the C5s or something with a default lower ratio. But if there's partly cached, you want to look and see how you're distributing that data. So you also will look at the Ganglia too, that you can look and see if things are spilling to disk, and then you might, have thought you were supposed to be compute optimized, and you might need more memory optimized. Similarly with the storage, these are going to have different attachment types of storage, and that's the data that's actually persisted, and it's going to have higher IO through the disk. So it's not that working memory, but it's the attachment. As Spark gets faster and faster, a lot of times the latency we see is network. That network can be between your workers and your driver, or it can be on your executors or workers and to the actual disk. And so you can optimize on what type over here of the attachment type. These tend to be NVMe SSD drives, if you've looked at that in the GUI. And then you have the general purpose. So, and with this, I don't have the GPU instances talked about. We just know that if you're going to use a GPU instance type, you have to make sure that you're using a Databricks runtime version that is GPU enabled. And that will be right in the GUI, or on our web page, you can see that. So again, you want to think about the ratio of cores to memory and your types of storage. And the largest cluster maximum number of cores you can spin up on Databricks right now is 96 cores per instance. So they can get pretty big. And this is just where you look at the number of workers and the max workers and your instance types. So you can see you can select your worker type, and you can have it the same as the worker or driver, or you can have them different. And that's where we usually recommend you start with the same, and then you can start to look and see if you have any bottlenecks, and you can see that in the Ganglia. We also often recommend that you start with fewer bigger instances is better than many small instances. And this is what I said, because a lot of problems or a lot of slowdowns now are actually network traffic. Let's see. And when we also look at the size and number of tasks for the largest stage. So this is, you can see this in the Ganglia. You can also see it in the Spark UI for the number of tasks. I have a slide that will talk about the tasks and jobs, but you want to think about how your data is actually distributed and what type of workload, again, going back to what the user is. Is it machine learning? Is it streaming? Streaming might have a lot of small data trickling through. Data science might need those larger clusters, would be able to do more tasks. In the shuffle partitions is where you're really starting to optimize, and you're just looking at the size of these shuffle partitions, and you can see that in the Spark UI and the Ganglia. If you're having a lot of shuffling going on, you're going to see that in a job. Okay. So with the I actually go. Okay, so this is a little bit this when you're really starting to look at the tunes. This goes with tuning. The previous slides of looking when we go to Ganglia and the Spark UI. Jobs here, we're talking about the internals of Spark. This is not the jobs that you're thinking about when you're automating jobs and running workloads. We had that jobs, it's now rolled into workflows. This is different. This is internal to Spark. So internal to Spark, you have two different things that can happen. We can have transformations or we can have actions. In action, transformation is exactly what we sound like. Hey, you're making a plan to modify a data frame. And so it tells Spark says, go do some data transformations. I'm going to create this plan. It doesn't happen. Spark is lazily loaded, meaning if I just create a plan, Spark doesn't do work until you tell it to have an action. When an action goes off, and if you ever in interactive notebook, you're like, wow, this join only took a fraction of a second. You probably created a transformation and Spark didn't do anything. It just created a plan. To do an action, which a common one is if you do a show or something in an interactive notebook, that is an action that's going to trigger things to happen. And it's broken down in this. An action creates a job, which then has these stages and these tasks. Again, the reason you care about this is the tasks, the slots, and the cores. So when you're sizing your cluster, this is how it's being spread out. So you have a core executor with more cores. And you have a task intensive. You'll see this in the GUI where you can see how you're utilizing your executors fully. So, and the task is the smallest amount of work that can be done. So in general, and this is getting down to the details, but if you're looking in the Ganglia or the Spark UI, you want to, in general, the rule of thumb is that no executive task should consume more than 2 gigabytes of memory. This helps you avoid overflow. So let's see. And in general, when you're looking at the number of tasks, it's easiest for Spark to do it as a multiple of the cores.
Hey, Carrie.
Yes.
I've got a question. I'm going to go ahead and Sandeep, I'm just going to unmute your microphone so you can go ahead and should be permitting you to talk if you want to go ahead and unmute and ask your question.
Hey, had a question regarding the sizing of the cluster.
Mm-hmm.
So, for instance, I have like one of my engineers configured like a 5-node cluster with like 32 gig RAM. But in reality, my job only needs maybe like 2 or 3 nodes with like 8 gig RAM each. So is there a way I can know from the Ganglia metrics that, ideally this should be the cluster size and you're like really upsizing it and you don't need to? Can I know that from any of the metrics?
Yeah, that's actually a good question. I'm gonna, over here, I just hopped over into the workspace. For those of you who don't know, when you go look at Ganglia, it's under metrics in the Ganglia UI. So this is a shared cluster that we have that runs on, it's Databricks. It's what we, it's a very large cluster, Autoscaling, and it's a high concurrency because many of us just hop on this and use it. So it gets some information. When you're looking at Ganglia, it gets a little confusing at first, but there's a lot of good information here. The big thing to note is these 4 major groupings here that we have. We've got the cluster load last hour. That's because I'm on the hour. Memory, CPU, and network. This is for your overall cluster. So that means it's your driver and all your workers. And this is the live snapshot. So the number of workers that are up right now. So what you can start to do is you want to look at this red line and see that this is the max memory, and see, are you getting up to that red line? Up here, we're seeing that we're reaching actually pretty close to the max CPU. But keep in mind when you're looking at this is for your entire cluster, not an individual worker. As I mentioned before, sometimes your limited by the driver, and sometimes you're limited by the executors. So what you want to do is look down here. These are actually some graphs for all of the individual nodes. So your driver and your workers. So usually what I like to do is look at the menu. Oops. You can scroll here, which is a little bit tough to scroll, but we can change the different things. And I'm sorry, did you say memory? Was your question, I think?
Yep.
No, I'm having. I'm trying to get my memory report and I can't remember the name of it. I'm gonna quick look at CPU, and the memory report is in here. I'll try and find it. CPU. So in this similar, oh, actually that's how we are looking at a CPU report. And what you can start to look at is looking at and we have one of these from memory. I just can't seem to find it since I'm live. Oh, that's why I have one.
I can always add later.
Thank you. Yeah.
In the email or something.
Okay, we'll do that. So in here you have these reports that have for the individual clusters and, or I'm sorry, the individual nodes, and you can see the % utilization. On a memory one, what you would see is that the driver node is the worker nodes are not utilizing their memory. So similar to like up here, you'd see just very low down here. Now you might ask, I've got several graphs down here. How do I know which one of these IP addresses? One of the best ways to find that is to go look at your Spark UI. And then under the executors for your cluster, you can see the number of active, dead, total, and the dead just means it's been killed or just not being used. So these are going to have the details of the executor, including the driver. I like to just switch here and search on the active ones. And then you're going to see it listed. The ID is going to be the driver. And you'll see this IP address. And then you'll see what's happening on these. So this is the Spark UI. That's just the way I like to find the driver. You can kind of guess and see it on the Ganglia, but I just like to know because sometimes things are a little confusing on that. So, you know, with the different nodes, you're going to look onto, this is just a worker, and you can start to look at this is the CPU one, but you'd look at the memory and you'd start to see how much memory you're actually using on that and if it's oversized for what you're trying to do.
So yeah, that helps. Thanks. So is the general guidance like I don't need to downsize as long as my memory is hitting like 80% average across nodes? Yeah. Okay.
And what you'll start to get when you start to look at these views a little bit more is when you're in the Ganglia, like I said, this is the overview. You're really going to start to look at these and see what the nodes are. If you want to look at the last day, week, month, year, you're going to start to see how this memory usage has changed. And you'll start to see that, you know, on these ones, this is the CPU. Things have obviously been kicked off and it's rolling out to the other, the workers at a certain time. So you can start to see a sort of temporal of what's been that load when things are being kicked off and if you're hitting that peak. And if that you want to see, do I want to add more nodes because I think it can be scaled out, or do I want to add more memory or more CPU depending on where you're having that. And this is just another view that people aren't always aware of, that you can dive into these. You're going to get different metrics of these different nodes, but you can see details on what you have of your CPU utilization, the load, your memory. And what's also interesting is you're going to see the most full disk partition. And so you can start to dive into those different parts of your cluster and see what's happening. If you saw some of these executives being very uneven, you're going to start to worry about shuffle and that you don't have a well-balanced set. So you're going to be stuck by that long pole of the slowest executor. Make sense?
Yep. Thank you.
Okay. And that actually, shuffle partitions, that's right where I was at. So perfect. So the number of shuffle partitions, and when you have an uneven, so when you have data movement, you want to think of what types of shuffles you're going to do. The types of joins versus a broadcast join, where all the data has to be, in this one we have a narrow transformation, the input outputs on the same partition. So we're not going to see a lot of network traffic here. When you're doing a wide partition, you're going to have to shuffle the data, and this is expensive. So if you're having some very slow, you might be doing some shuffle, and then you might have uneven data sets, and that's where you're going to see your executors either memory bound or CPU bound very different. And with that, if you see your executors in the ganglia having, and usually it's memory, you usually first look at the cluster or the memory. You want those workers to all be executing roughly the same. Now, and that's true, especially when you're testing in isolation. If you've got many users on your cluster, you're not going to be able to isolate one job. But if you have a job itself, or I'm sorry, a process that's taking too long, you can put it on its own cluster, and then you can dive into that ganglia a little bit better and see where that bottleneck is and see if you're scaled properly. So this is just, one of the first things, if you bring one of those Databricks people in there, first thing you ask, tuning is, can you tell me the type of queries or transformations you're doing? And what we're really doing is trying to figure out this narrow transformation, wide transformation, what is happening with your data? Can we split that data across the whole clusters in the executors, or does each executor need to have a full copy of the data set, and you size your cluster differently for that? Okay, so going back to the ballpark of when you're looking at different partitions, and I should have put it on the slide, but one of the first things we are starting to recommend is, like I said, using the most recent Databricks runtimes and doing the auto optimizations. But if you need to know how large your partitions should be, it's the answer somewhere between the largest shuffle read over 128, 1 gig. So if your shuffle partitions are too small, you may be adding, unnecessarily adding more tasks to the stage. But if your shuffle partitions are too big, you get a bottleneck with the network. So what you want to do if you're really tuning this and something's taking too long, you want to identify your longest job in your Spark UI, click on that job, and sort by the shuffle read size, and then that's how you're going to find the largest partition. So with that, you're going to look at your jobs. Then you go look at your duration. And then you're going to start looking for the different shuffles on this. Okay, so some examples of with a scenario, if we have 100 cores, 150 shuffle partitions, and 750 megabytes shuffle size. Some of the you might want to consider is if that 150 shuffle partitions is either too many or too little. So with this, you might want to try decrease the shuffle partitions to 100. And then you have the 1.125 gigabits average shuffle partition size. Then you have the one cycle of tasks, so you're able to reduce tasks. But the other option is if you want to try and increase the shuffle partitions to 200, this will actually give you the smaller shuffle partition size with more cycles of tasks. So these are just some of the way that you can look at tuning options. Again, this is pretty detailed. You first want to really try and get those cluster sizes and then see if you're having any unbalancing. I'm going to. So moving on, and we have, for those of you that have access or are interested, there is a Spark best practices class that we have on the Databricks Academy that goes very into depth about shuffling and spill and the 5 most common problems that people see on their performance, which of course rolls into tuning. So that's there's an instructor-led class and then there's a non-instructor, and those are very good to go in, a several day thing of what I tried to cover in a couple minutes. But for driver node sizing, so again, driver nodes typically don't do too much resource intensive tasks like the workers, because they're really doing the coordination for the workers. However, the exceptions are when you have large data sets that need to be returned to the driver, when the driver is doing heavy lifting for complicated graphs and visualizations, or when it's broadcasting large variables, meaning that those variables have to be collected to the driver and then sent to all the workers after that. So it's a broadcast. Oops. Oh, and then finally, the parallel threading tasks are being executed on the driver, which is really some of the management that it handles of the workers. So a question could be is, how large is a large data set? And this comes back to a rule of thumb of try not to exceed 20% of the total memory on the driver node. So this will leave room, because we had that slide before that showed you've got the storage and the memory, the working memory and the storage memory, but you want 20% of the total memory. And this leaves the room for other tasks in the garbage collection and reduces that chance of getting those pesky out of memory errors. Some other best practices when we're thinking about what is your scenario is if you're in development versus production. So with your data set size and you're doing a lot of experimenting, you might start your development cycle with identifying the large data sets and then paring them down to size, and then you can work faster and more efficiently while you're doing the development. So, this does have to be done intelligently in that you want to have good samples of your data and your large data sets, and always ensure that your keys and your joins can still be successful. But it is a way, if people have very large data sets, the benefits of this is you're going to reduce some production time. When mistakes happen, because development is all about iteration, they're a little bit faster to clean up. And then it can help you get more of an idea how to right size your cluster. And it might take a little bit of time to take your data set and pare it down, but you'll probably save that in your experimenting time. So it's just one of those thoughts that can help with the development costs. We talked about this a little bit before, but the cluster type, the cluster mode of the standard versus high concurrency. Standard clusters are a lot of times that single user any language. And the high concurrency is that resource sharing. So this is just good to make note of. If there's multiple users that are sharing a standard cluster, they might have some problems with resource sharing. Spark is not doing as much planning ahead for that resource sharing, and they aren't getting fault isolation. So on the high concurrency, that means if someone's notebook, it just safeguards your users from each other. So one notebook can fail much more than the other ones are going to continue on happily. So the typical use case is several users sharing this high concurrency. So another way to manage costs is with your cluster access control lists. So this is at a high level, you can set the different permissions for who can manage and who can create clusters. So this allows people to, platform teams or just teams, to decide who wants to be the administrator, how do you want to do this? And if you're concerned about costs getting out of control because people are spinning up clusters and not understanding what they're doing and not using them, you can manage it with your cluster ACLs. Oops, sorry. So that's the different permissions are attach, restart, resize, and manage. We also mentioned this in the other GUI. We have the auto termination, which is just the terminate after how many minutes of inactivity. And then auto scaling. So with auto scaling, Databricks is allocating workers to account for the size of your job. So parts of your pipeline might be more computationally demanding than others. So it will add workers during these phases of your job. So this, once the disks are no longer needed, they can be removed. And depending on and just keep in mind that auto scaling, it does take a little bit of time for those workers to come on. So it's not going to be instantaneous. So sometimes you would think that triggering of auto scaling would happen, and it's just not been computationally expensive enough to trigger those additional workers. Oops. Okay, so the other types of instances with the on-spot versus demand. So an on-demand instance is one that you fully control its life cycle. You decide when to launch it, you decide when to stop, hibernate, reboot, etc. Spot instances are unused instances that are deeply discounted usually. So spot instance prices vary on the availability zone, and it's based on the long-term supply. So your spot instance runs whenever capability is available, and then there's a maximum price per hour. So you can save a lot of money with spot instances. Your big risk is your workload could fail if spot instances are revoked. So, and this is one of those that you can see this on the different cloud vendor sites of what their prices are and how they're discounted in the time of day, such things. Okay, so we also talked about cluster tags. So cluster tagging is done, and again, these can be done with the API or through the GUI, but this allows you to monitor costs by department, project, line of business, or whoever's doing the tagging. So with that, you can set that right there, or it's in, again, the API when you create your clusters. The other option that we talk about a lot with your cluster management is the pooling. So Databricks pools reduce the cluster startup and auto scaling time. So it does this by having a set of idle ready to use instances. When a cluster is attached to the pool that needs an instance, it tries to find one of those in the instance pool. If there aren't any idle instances, the pool expands. When a cluster releases the instance, it returns it to the pool and it's free for another use. Only clusters attached to a pool can use that pool's resources. Okay. So pricing considerations. So we've talked about with the savings cost of just how you're actually going to select your cluster with the persistent versus ephemeral. So persistents are the ones that you're turning on, ephemeral are turning on and off, on demand versus spot, the cluster policy and the pools. And then with the monitoring, we can get the logs. You can get log delivery to your different accounts. The chargebacks, first recommendation for when you're doing chargebacks is to do cluster tagging. We have some sample notebooks that show how you can get the cluster logs delivered to a S3 bucket or ADLS and how you can start managing those at a lower level cost or lower level. Okay, so we've talked about this a little bit, and I know we're getting close to the top of the hour, but managing the performance, we hopped over and saw a little bit, and we'll go a little bit more into the Ganglia metrics. So this is just a screenshot. So again, this is the Ganglia metrics. Ganglia is included, obviously, we show built in, and that's where you see the customer's compute and RAM being used. In the Ganglia, the Spark UI is where you can look at the job and its stages and tasks. Remember that it kind of goes, jobs are created, stages, tasks, and you can dive into where you're getting bottlenecks there. So with the cluster, with the Ganglia, it's the aggregation over, again, this is the aggregation over the entire cluster. So it's really your first glance. You really don't want to be near the 100% utilization for the CPUs, because that means extra work is probably be putting on your driver, because it is that summation over the whole cluster. So when you're looking at the network over here, this monitors the traffic in and out of the cluster. So green indicates the data being read, and then the blue indicates the data being written out. So once the application fits into memory, the application can tend to become network bound, especially if you have distributed group buys and transformations. So one of the ways to look at the shuffles, like we talked about, is going over to your Spark UI and then looking for the under the executors, you can start to look at the different shuffles. So when you start looking at shuffle reads, you can see it correlated to the different stages. And when you go to the stages, the way I got here is I went to the Spark UI and I was looking at the different stages, and this is where you can see the DAG visualization of what's actually happening. Because I'm just doing this live, there's not actually a lot of complicated stages going on, but this is where you'd see staging and parallelization and the different task aggregations. This only has a single task, so it's not terribly interesting, but you can find your logs down here.
Hey, Carrie. We've got a question in the box saying, in the past, streaming jobs were not recommended to be run with autoscaling. Is that still true?
Yes, that's a short answer. I can follow up for the details on why that's still. And the other thing to note, actually, when you're looking at the Ganglia and streaming is, and for cost optimization is, if you don't need things truly streaming and you're just seeing the driver having a lot of CPU and nothing going on in the workers, you might be improperly sized. So for streaming, you don't want the auto scaling, and then you want to look at the size of your drivers and your workers.
Just one quick plug for Delta Live Tables. So Delta Live Tables is one of our ETL, or the ETL pipeline method that we kind of have put forth in Databricks. And so that is a feature that is actually, there will be streaming auto scaling for Delta Live Tables going forward. I'm not sure exactly when that's released. I can try to include that in the email following up this as well.
Okay, thanks, Stephanie. And we're getting to the top of the hour. So this is the summary of some of those tips and tricks for actual performance of leveraging data frames and Spark SQL APIs first. Use data frames before UDFs. This is a performance. It has to do with the serialization. MLlib is going to help you scale your machine learning models. A lot of the commonly used machine learning packages are not natively parallelized, but MLlib does. Think about when you're doing ML training of how, if you want to do the caching option. And with the caching option, then you want to think about how you're sizing your clusters. Similar with the cache for BI tools. Oops. And this is a big one that's sometimes overlooked if you're not in the data engineering pipeline. Number 6 is really talking about the lakehouse architecture. How if you have CSV, JSON, or raw, to really switch to this Parquet and Delta. For those of you not familiar, Parquet is just columnar, and Delta, they're based on columnar storage, and they just work, they scale better than you're going to get with the CSV and JSON. You're going to get less network traffic. You're going to utilize your Spark cluster much better. I have a link for some data frame. And again, Delta tables, that goes with the Parquet and Delta. You get out of the box performance, and we didn't talk about it, but you get data skipping is very powerful. So Spark is intelligent looking at, how do I scan less of the data? How do I return just what you need? And then there is this bytes per partition. It's how big your partitioning on your Spark cluster is and where the execution will be. That is right at noon. So I just, thanks everyone for attending.
Thank you. We hope to see you all at the next Skill Builder session. Thank you. And enjoy Data and Ice Summit next week. We've got a question, Craig. Oh,
It's Jivitesh. Welcome.